This module is an introduction to hypothesis testing. In inference, we used a sample to draw a conclusion about a population. Two types of inferences are the focus of our work in this course. First, estimate a population parameter with a confidence interval, which we've done, and also test a claim about a population parameter with a hypothesis test. That's the one we have not done yet. We can also use samples from two populations to compare these populations. In this situation, the two types of inference focus on differences in the parameters. First, estimate a difference in population parameters with a confidence interval, which we've seen, and then also test a claim about a difference in population parameters with a hypothesis test, which will be the new part that we haven't seen yet. Previously, we learned to estimate a population proportion using a confidence interval. For example, we estimated the proportion of all Tallahassee community college students who are female and the proportion of all American adults who use the internet to obtain medical information in the previous month. We will revisit confidence intervals in future modules. Now we look more carefully at how to test a claim with a hypothesis test. Statistical investigations begin with research questions. We begin our discussion of hypothesis tests with research questions that require us to test a claim. Later, we look at how a claim becomes a hypothesis. So for example, research questions about testing claims. Let's look at that. So here are some examples of research questions that include a claim about a population parameter or a claim about a relationship between two population parameters. The first one being, is the average course load for community college students less than 12 semester hours, or 12 units, I think, in other words? This question contains a claim about a population mean. The population is all community college students. The variable is course load in semester hours or number of units. It is quantitative because it's measured in numbers, so the parameter is a mean. The claim is the mean course load for all community college students is less than 12 semester hours. Another one could be, do the majority of community college students qualify for federal student loans? This question contains a claim about a population proportion. The population is all community college students. The variable is qualify for federal student loan, yes or no. It is categorical because yes or no is not a number. Those are the only answers you could give. They're not numbers, so it's categorical, not quantitative. So the parameter is a proportion. The claim is the proportion of community college students who qualify is greater than 0.5. A majority means more than half or 0.5. Because remember, one half is 0.5. So half of all community college students. A third one might be, in community colleges, do female students and male students have different mean GPAs? This question contains a claim about that, a claim that compares two population means. The two populations are female community college students and male community college students. The variable is GPA. It is quantitative because it's measured with a number, so the parameters are means, not medians. The claim is the mean GPA for female community college students is different from the mean GPA for male community college students. Notice that the claim compares two population means, but there's no claim about the numeric value of either mean. We don't really know what the means are, but we're assuming one's going to be larger than the other or smaller than the other. A fourth one might be, are college athletes more likely than non-athletes to receive academic advising? This question contains a claim that compares two population proportions. The populations are community college athletes and college students who are not athletes. It's comparing those two. The variable is receive academic advising, yes or no. The variable is categorical, just like the third example up there. So the parameters are proportions. The claim is the proportion of all college athletes who receive academic advising is greater than the proportion of all non-athletes who in college who receive academic advising. Notice that the claim compares two population proportions, but there's no claim about the numeric value of the proportion, kind of like the last one.